So today I'm going to talk about data science, a capstone program, which is actually consists of students who work on externally funded projects. First, I'll start off by describing our center a little bit. We lovingly call it the D2K lab, but it has like a mouthful. It's called the Center for Transforming Data to Knowledge. Basically, it's a data science institute or a center, and the focus of the center is primarily teaching, but we also engage in research. The goal is, to train undergrads and grads and um, make an impact in the data science community through education. So we provide a lot of interdisciplinary experiences for students, and the focus is immersive learning or experiential learning. And our flagship course is actually the D2K Capstone course, which I'm going to talk about in detail. But we also have a very interesting consulting course. We call it Consulting Clinic. And we also have courses on Intro to Data Science, and we're building more courses on data science like Intro to Deep Learning and NLP and other areas. We also host a number of programs and events throughout the year, like hackathons and workshops and seminars and so on. So we have some partners and affiliates who work with us and collaborate with us. They include researchers from inside RISE and the Texas Medical Center, which is a really big center for a lot of hospitals and medical research in Houston. Um, we also have a lot of government and nonprofit organizations like the City of Houston, the Houston Police Department, and so on, and also a lot of projects from the industry. So let me move on to our capstone program. So the capstone program was developed uh, inspired from other capstone programs in engineering and computer science, where there are client-facing projects and students who work directly with clients to solve real-world problems. So in our capstone program, students are generally split into teams of 4 to 6, usually for a semester, and sometimes even for year-long projects, like a long project which is split up into 2 semesters. So all our projects are client-sponsored. They use real-world data, and we encourage the projects to be open-ended. And all our teams are both vertically and horizontally integrated. What that means is that vertically we have undergrads, masters, and PhD students all enrolled in this program. And also we have students from multiple disciplines across the campus. Um, in fact, this um, capstone course is actually a requirement for some and elective for other degree programs at Rice. For example, there is a data science minor for which this is a requirement, and it's an elective in computer science, statistics, ECE, applied math, physics, and a bunch of different majors. So the challenge for this program is actually the client facing aspect. So like I said, the teams work with actual clients outside the um, the closed D2K lab, and which entails working with data owned by the client very often. So what we provide is a template sponsored research agreement, and we need to get that signed from the client and ourselves, and that includes details on how data will be transferred, how data will be used, and so on. Um, so we have non-confidential data, like maybe publicly available data or data with less restrictions directly shared with RISE. And students are given access to confidential data in a controlled environment, like it's in a server from where they cannot remove the data, or maybe it's on a machine on AWS or Azure from which they cannot move the data. So it's just like a closed, controlled environment where the data is provided to students. In general, we will start soliciting projects from our partners 3 to 4 months before the start of a semester. And then we look through the proposals and we directly work with them, iterating over the proposals to set up the project. We do emphasize that the project must have an educational component, and the objectives must be clearly stated so that students can start working on them, and they must be challenging, and we encourage them also to be open-ended. So the curriculum is basically the development of the project by the students, and we provide some lectures and materials and guidance with respect to what we call a data science pipeline, um, and how to design that, and what technologies they might use for designing the data science pipeline. We also discuss ethics with them. This includes data privacy and fairness and other ethics concerns in data science. We talk to them about project management, and we encourage good communication skills. And we continue to give them feedback throughout the semester to improve their communication skills. So through our course, we developed a kind of framework which we call the data science pipeline, which the students can follow step by step to start from a given question or the data and go step by step, one at a time, and reach the end of the project. Um, so first, we encourage them to look at the background of the problem, both in terms of domain knowledge, as well as we encourage them to do literature review, and then they have to do data wrangling because it's real world data, it's not cleaned. And we encourage them to do exploratory data analysis and then move on to modeling and have plans for validation and finally communication. Um, this is a framework that we've built with our experience in teaching these kinds of courses, and also inspired from other pipelines for software development and um, a product development in the industry and in engineering disciplines. So this is an example course structure from Spring. As you see, we have some lectures, and also at the end of lectures, we meet with the students one-on-one. We have 3 rounds of presentations and reports due, and we also check the software of the students twice a year and also for the final. Um, and we try to ensure that they follow the best practices in software development so that it's already at a professional level, and they can hand it off directly to their clients, and they will have no problem in using the software. Um, just quickly, an overview of how we grade. So we stress on individual grading a bit because it's a capstone program and students are in teams, so it's difficult to have individual grading. So what we encourage is peer evaluations. So students can submit peer evaluations 2 to 3 times a semester through a website called catme.org, and we compile them and we also release them to the students after anonymizing them. The instructors also evaluate the contributions of the students, and sometimes if we have questions, we ask them to write like a one-page uh, memo where they describe the contributions of every student, and that's how we grade them based on individual contributions. And class participation includes discussions in the classroom and participation in the small team meetings that we have with the instructors. But the bulk of the grading is actually the team products, right? So we have 3 rounds of presentations and reports and software checks, and the interim evaluations constitute 15% of that. And the bulk of the grading goes into the final report, and some parts of it into presentation and the software. So I'm going to present the results of 2019-2020 because 2020 and 2021 is not yet over because we are teaching this course over the summer as well. Uh, so as you can see, we have a decent demographic diversity. Male to female ratio is not really 1:1, but we're trying to get there. Um, and as you can see, although it's offered primarily for a data science minor undergraduates, but a lot of graduate students also enroll. And we have a good diversity in terms of departments. As you can see, like a major part of the student body consists of statistics, CS, and ECE. So for this academic year, there were 15 teams and a total of 76 students. And we actually create the teams by hand. All the instructors, we sit down and create the teams where we ensure that there are men and women on every team. Every team consists of both undergrad and grad students, and we try to have at least 2 majors represented in a team. Um, Looking at the feedback, 54% of students say that they have an outstanding experience, and 32% said the experience was good. A lot of students, 87%, said that the course was extremely challenging, and 89% of the students said that they would be more confident in tackling a large-scale project after taking this course. So we believe that students are satisfied, and we're providing them a good level of training for them to go out into the real world and solve real world data science problems. So as far as the diversity of the teams, as you can see, we have a fair balance of industry teams, which are like company, and there's energy companies, finance companies, tech companies, and we have some teams which work on projects from the Texas Medical Center, like I mentioned, and also there are teams working for not-for-profit companies and even for local government agencies. And as you can see, the data science area column, there is a wide variety of projects that we get. It could be machine learning, which is the primary focus, of course, but there are also projects on statistical modeling, natural language processing, and this time we also have projects on computer vision, which is a bit rare, but we have one this time. Um, the sponsors are mostly satisfied, but sometimes they're not. Um, so it's a fine balance between trying to satisfy sponsors, um, assuring that the learning outcomes are achieved, and ensuring student satisfaction and so on. So it's a very fine balance trying to set all these up together. So if you go to our YouTube channel, you can see a lot of 1 to 3 minute presentations from a lot of our teams who've worked from 2019 through now, and we have some of their brief summary of their projects over there if you're interested to look at that.